Hi, I'm Paul, an iOS developer at Livefront, and this is Sticky Footers in SwiftUI. I've got a problem with the app I'm working on. The design team wants to add a sticky footer to the bottom of the screen. Let's find out what that is and how we can implement it in SwiftUI. Here's the main screen of the app. We have a list of presentations and a footer message at the bottom. But the number of talks is growing quickly, and they can no longer fit on one screen. And now we have a problem. The message at the bottom is interfering with the content and making it hard to read. The designer wants to keep the message stuck to the bottom of the screen as long as there's enough room. When the list gets too long, it should push the message off the bottom of the screen. So how can we do this? We actually want our footer to be in one of two modes. One mode is stuck to the bottom, like we have now. The other mode is scrolling, where the footer message scrolls with the rest of the content. Let's add another footer for this mode. Now, to get the effect we want, we need to show only one of these footers at a time. When the content is far away from the bottom, we show the footer stuck to the bottom. When the content is close to the bottom, we show the scrolling footer. The switch happens when the two footers frames, their locations on the screen, fall at exactly the same place. Let's add some state to model this. The footer is stuck to the bottom when the scrolling footer's frame is less than or above the stuck to bottom footer's frame. This means we'll also have to record state properties for both of these frames. Now, we need a way to update these frame values whenever the footers move. There's no built-in way to easily do this in SwiftUI, so we'll have to write our own view modifier. This modifier will take a binding to a frame state property and automatically update it when the frame changes. Now, let's look at how this modifier can be written. Here we've started to extend view with a new modifier function that takes a binding and returns a modified view. First, we'll add a geometry reader to the background of this view. Geometry reader is SwiftUI's mechanism for reading the frame of a view. It can sometimes interfere with the sizing of the view it's reading. By putting it in the background, we're making sure this can't happen, because background views automatically match the sizing of the original view. We can use the geometry property to get the frame of the view in the global coordinate space. That's the location relative to the entire screen. Now we have a problem. Geometry Reader is supposed to contain a view, not a frame. But we don't want to add anything that can change the appearance of the original view. So we'll add an invisible color view. We still need a way to give the view's frame back to the binding. For that, we're going to use, or rather misuse, SwiftUI's preference system. Preferences is a way for a SwiftUI view to set a value which can then be read by other views whenever the value changes. Here we're going to be communicating with ourselves rather than another view. The value we're going to set is the calculated frame of this view. In order to set a preference, we need a preference key to tell the system what type of value we're storing. We'll make a key for storing a frame's rectangle. A preference key needs a default value and a reduce function which tells the system how to combine multiple preference values if necessary. We won't be combining values, so we'll simply return the value we're given. Now, we can use our new preference key to store the view's frame. Alright, we've set the value. Now we need to read it and pass it along to the binding. The onPreferenceChange handler is called every time the corresponding preference changes. Now we can set the binding's value. And that's all we need to build a readFrame modifier. Our last step is to show or hide the appropriate footers when isFooterStuckToBottom changes. When the footer is stuck to the bottom, the scrolling footer should be hidden. Otherwise, it should be shown. The opposite is true for the stuck to bottom footer. When stuck to the bottom, it should be shown. Otherwise, it should be hidden. As you can see, we now have only one footer visible, and we can scroll the content until it approaches the footer, at which point the visible footer switches, and now we see the scrolling footer getting pushed off the screen. And it even works with a long list. Reading the frame of a SwiftUI view is a powerful tool that can be used to create many advanced layouts. Be careful not to change a view's frame immediately after reading it, or you may find yourself in an infinite loop of reading and updating. Thanks for watching.